All right, go ahead and take out your homework and open up your books to page 16. We're going to start by looking at the 1 through 18 that you did for homework last night. Pages 16 to 17, just practicing with reciprocal identities. We need to memorize who's the reciprocal of what, because you need to know which one to do on the calculator. Now, sine, cosine, tangent are easy, right? We have that old Indian saying, Quentin. I guess Sokato, right? It helps us remember, class, that sine is what over what? Cosine's what over what? And tangent's what over what? Toa, opposite over adjacent. But we need to remember which reciprocal goes with what. What are, first of all, the three reciprocal identities? I was asking Jamie.
Cosecant, secant, and tangent, cotangent.
There we go. Cotangent, secant, and cosecant. Now the question is, which one goes with which? What is cotangent the reciprocal of?
Tangent.
Tangent. What is secant the reciprocal of? Cosine. And what is cosecant the reciprocal of?
The sine.
The sine. Okay, so make sure we keep those reciprocals straight. We come now to numbers 1 through 18 on pages 16 and 17. 17. And good. Number 1, if the tangent is 1 over 2, then the cotangent would be, Jamie?
2 over 1.
2 over 1. Or just 2. Or if you want to do the 3 decimal place thing, 2.000. If the tangent of W is 0.25, then Chris, the cotangent would be 4, or 4 over 1, or 4.000. If the tangent of B is 2.5, Quentin, then the cotangent would be 0.400. There we kind of have to go with a decimal, so we need the 3 places. Number 4, if the tangent is 0.10, then the cotangent, Jamie, is 10. Or 10.000. Number 5, if the cosine is 1 over 5, then the secant would be, Chris? 5 over 1, or just 5, or 5.000. Number 6, what did you get for the secant, Quentin?
2.900.
That is not what I had, Jamie.
I have 2.857.
2.857, so that's where you want to put it on in the calculator, 0.35, and hit that reciprocal button. Maybe double check real quick.
I had 2.89.
Okay, double check, put in 0.35 and hit the reciprocal button.
I must have rounded.
Okay.
Yeah.
All right, yeah, 2.857. Again, set the fix to 3 places. Let's see, number 7. Back to Quentin for redemption. If the cosine of theta is 0.45, then the secant is 2.222. And if the cosine of L is 0.15, Jamie, then the secant is
6.667.
6.667.
Okay, number 10, or number 11.
Number 9. If the sine is 0.98, then the cosecant, Chris, is
8.3.
Oh my. Number 9, 0.98.
Oh, 1.02.
1.020. Number 10, if the sine of B is 0.12, then the cosecant, Quentin, is 8.333. Number 11, if the sine of B is 1/3, Jamie, then the cosecant is
3 over 1.
3 over 1, or 3, or 3.000. Number 12, if the sine of A is 0.012, then the cosecant, Chris, would be
83.3.
Well, if we're going to do decimals, we want 3 decimal places. So 83.333. There, it just happens to repeat the 3. 83.333. All right, questions on those? All right, well, let's go to numbers 13 through 18. And here they kind of did a variety of things. Secant is 2, cosine class is
1/2.
1/2 for number 13. If the secant is 2, then the cosine should be 1/2, or 0.500. Number 14, if the tangent is 4.5, then the cotangent is
1.67.
0.222. For number 15, if the cosecant is 6, then the sine is 1/6, or 0.167. Number 16, if the sine is 1/3, the cosecant is 3, or 3.000. Number 17, if the cosine is 0.8, then the secant is 1.250, or if you remember that 0.8 is 4/5, 5/4.
I think I did them.
All right, and number 18, if the cotangent is 1.32, then the tangent is class
0.75.
0.75.
Yeah, I just did them out of order.
So we got to pay attention so we don't make those kind of mistakes. It'd be a shame to do that on a quiz or test.
Down instead of over.
Okay. Questions on this? Questions on reciprocals? Should have been a pretty quick, easy assignment as long as we stayed in order. Let's take a look at number 27 on the previous page. Go back to page 15 now. And let's go over these where given one trig ratio, you are expected to be able to find the other two. We're given the cosecant of A is 17 to 8, and we're asked to find the sine of A, the cosine of A, the tangent of A, the cotangent of A, the secant of A. And we don't need to find the cosecant because it's already up there. The easy function to find, of course, is going to be, Quentin, the sine, because it's just the reciprocal. It is 8 over 17. But all of the other ones, we need to do a calculation first, because we know that if cosecant is the reciprocal of sine, and sine is, then cosecant is hypotenuse over opposite. So what we're missing then, class, is the adjacent. And we can find the adjacent using, Chris, the diagram theorem. And when we did, we found the adjacent to be? Number 27?
Yeah, 8, no, 15.
15. By the way, that's a triplet then, isn't it? Because these came out integers. 8, 15, 17 is a Pythagorean triplet. And so now we can find the cosine, which is whatever what class? Adjacent over hypotenuse. And adjacent over hypotenuse would give us, Chris? 15 over 17. And once we get the cosine, let's get its reciprocal.
17 over 15.
Yeah, but what is the reciprocal of cosine?
Oh, the secant.
Secant, which is, there's the 17 over 15. Tangent, class, whatever what? Opposite over adjacent. Quentin gives us
15 over 8.
Opposite over adjacent.
I was looking at cotangent. 8 over 15.
8 over 15. And Jamie, he kind of said it, but once we get the tangent, we can get the reciprocal.
15 over 8.
Well, what's the reciprocal tangent?
Cotangent.
Cotangent, which is
15 over 8.
15 over 8. There we go. Because I'm constantly trying to pound these reciprocals so we'll memorize them. Now, if it doesn't catch from what I'm doing, you have to do it in your head. You have to do it at home as well. But I'm trying to pound those reciprocals so we'll memorize. How do we do on number 27? All right. Questiones? All right, Ethan, any questions? No, because you're not here. All right. Hopefully you're watching this video. All right, let's take a look at the next one here, where we were given that the sine of A is 2 to 5. And of course, if I'm given the sine of A is 2 to 5, I should go ahead and get the, what, Chris? Cosecant to be 5 over 2. But, again, we have to do a calculation to get everything else. We know that sine's what over what, class? Opposite over hypotenuse. So I know 2 is the opposite, I know 5 is the hypotenuse, so I need to find the adjacent, and this is not a triplet this time. It's going to come out to a radical value. What is that radical, class?
Square root of 21.
Square root of 21. Oh well, here we go. What's the cosine of A, Jamie?
It's the square root of 21 over 5.
Because cosine's always what over what, class?
Adjacent over hypotenuse.
Adjacent over hypotenuse. Once you get the cosine, go and get its reciprocal, class. Secant to be initially, Quentin, 5 over the square root of 21, right? We're doing exact values, not decimals here. So 5 over the square root of 21, but I can't leave a radical denominator, so I need to rationalize to get
5 times square root of 21 over 21.
5 times the square root of 21 over 21. For the tangent of A, Chris, tangent's what over what? So katoa.
The tangent?
Tangent. Ola. Toa.
Opposite over adjacent?
Opposite over adjacent, which in this case is going to be
8, no, I looked at the wrong one. 3, 2, 5. 2, 5.
Toa, opposite over adjacent. There's opposite, there's adjacent.
No, I had mine wrong. I had 5 as the,
Should be 2 over square root of 21, which would rationalize to give us
2 times square root of 21 over 21.
21, right? Because when you multiply this by square root of 21, it gives you the square root of 21 squared, which is just 21. And then remember, we said when we take a reciprocal, don't come to this rationalized form to flip it. That's a mess. Come to the unrationalized form and flip that to get the cotangent, square root of 21 over 2. All right, had a little trouble there on this one. How did you guys do? You got it. Also some trouble as well. Questions? Questions. So when I say exact values, no decimals, leave them as fractions, include radicals, and then there are other times I'll ask for decimals. Questions on that? All right, next section of notes, cofunction identities. Cofunction identities. We've actually looked at this already once before, and that is that if I call this angle A and I call this angle B, we said that, for instance, let's just make up some numbers here. Let's suppose that this side here is 3, and let's suppose that this side here is 4, and let's suppose that the hypotenuse class is 5. We observe that when you take the sine of angle A, which of course class is whatever what? Opposite over hypotenuse, so 4 over 5. And later you take the cosine of angle B, which cosine is whatever what class?
Adjacent over hypotenuse.
Adjacent over hypotenuse, make sure we're thinking. That would also be 4 over 5. And think about it, relative to A, this is the opposite. Relative to B, this is the adjacent. And the hypotenuse doesn't move. So obviously, sine of one, cosine of the other should be equal. That's always going to be true. That the sine of angle A will always equal the cosine of angle B. Similarly, the cosine of angle A will always equal the sine of angle B. Does that make sense? But it works for other things as well. Other times where opposite and adjacent get switched. For instance, think about the tangent of angle A. Class, what's tangent? What over what?
Opposite over adjacent.
Opposite over adjacent. But realize what is opposite to A is adjacent to B. And what is adjacent to B is opposite to A. What's opposite to B is adjacent to A. So tangent's opposite over adjacent if we're looking at A. But the same opposite and adjacent from B's perspective is adjacent and opposite. Or opposite and adjacent, excuse me. Does that make sense? So the tangent of angle A is going to equal the cotangent of angle B. Similarly, the cotangent of angle A, adjacent over opposite. Well, from B's perspective, that's opposite over adjacent, which is the tangent of angle B. Let's suppose we looked at the secant of angle A. Well, of course, secant's whatever what class?
Adjacent over hypotenuse.
Ooh.
Hypotenuse over opposite.
Ooh.
No, that's secant.
Secant.
Hypotenuse over
Hypotenuse over adjacent is the reciprocal of cosine, right? So if it's hypotenuse over adjacent, from the other angle's perspective, that's hypotenuse over opposite, which is cosecant. And for that matter, the cosecant of A, hypotenuse over opposite, well, from the other angle's perspective, that's hypotenuse over adjacent, which is secant. Again, notice the sine of one equals the cosine of the other. The cosine of the one equals the sine of the other. The tangent of one equals the cotangent of the other. The cotangent of one equals the tangent of the other. The secant of the one equals the cosecant of the other. Do you see how one of them has co and the other one's regular? That's why we call these cofunction identities. Now what's interesting here, tangent and cotangent are cofunctions. They are also reciprocals. Here's where students struggle. Sine and cosine are cofunctions. Sine and cosecant are reciprocals. So you have to keep straight what I'm looking for. Cofunctions basically just match the same words, just with one has the co, the other doesn't. But reciprocals are the flips of each other. Does that make sense? Now, what's the application here? Well, let's think about angle A and angle B for a minute. A and B are the two acute angles of any right triangle, correct? I picked random numbers, Chris, 3, 4, and 5, but I could have picked any numbers, or I could have picked no numbers at all. It doesn't really matter. A and B will always be what to each other, class?
Complementary.
Complementary. That's what the co stands for. Complementary functions. Sine of one angle, complementary sine of the complementary angle. Complementary sine of one angle, regular sine of the complementary angle. These are complementary functions. In your notes, write down that co means cofunction, or co means complementary. That's where this whole co thing comes from. So sine, cosine, tangent, cotangent, secant, cosecant. There seems to be a co a lot of times. Right, the co means complementary. Because angle B is 90 degrees minus angle A, isn't it? Therefore, we could say that the sine of angle A equals the cosine of 90 degrees minus angle A. The cosine of A equals the sine of 90 degrees minus angle A. And we get the idea, just come straight down. Function of one angle equals the cofunction, that means with or without the co, of the complementary angle. Look in your textbooks if you would now at page 16. Look at page 16. It says, write the sine of 28 degrees in terms of the cofunction. Well, how you do this is you would look at the actual function, you just ask yourself, self, what is the cofunction of that thing? And if it doesn't say co, make it say co. So this says sine. What's the cofunction of sine, class? Cosine. What's the reciprocal of sine? Cosecant. But what's the cofunction of sine? Cosine. And we're going to change this function to the cofunction, but we're also going to change the angle to the co-angle, the complementary angle. What is the complement of 28 degrees? Well, what's 90 minus 28? 62 degrees. On your calculator, find the sine of 28 degrees. 0.469, blah, blah, blah. Okay, now find the cosine of 62 degrees. Exact same thing you just had, right? That's why we call these identities. Doesn't matter what angle you make up. The sine of one angle and the cosine of the complement will always be equal because it's cofunction, co-angle. Does that make sense? Look at the next example. There's this, express the cotangent of 42 degrees in terms of the cofunction. Well, what is the cofunction of cotangent, class? Tangent. What's the reciprocal of cotangent? Also tangent, right? Again, those are both cofunctions and reciprocals somehow. All right, so we have the cofunction. We now need the co-angle, the complementary angle. What's the complement of 42 degrees?
58. Or 48.
48 degrees. Careful, subtracting from 90, not from 100. 48 degrees. On the calculator, take the tangent of 48. Let's start with the easy one first. Take the tangent of 48.
1.110.
Okay, now take the tangent of 42, but then take the reciprocal of that. So tangent of 42, but hit the reciprocal button to get the cotangent of 42.
Same thing.
Same thing, right? And this could work for the other functions as well. Questions on these cofunction identities. Again, these things that are always going to be true no matter what angle. In fact, Chris, make up a rather random sounding angle.
Can it be a decimal?
Oh, yeah, you can have a decimal.
22.2645.
22.2645. Remember, the worse you make it, the harder it is for us to enter it, but whatever. And fortunately, you stopped at 4 decimals. And pick one of our trig ratios, any of the 6.
Sin, cosine.
Oh, we already did sine and cosine.
Fine, I can't see. Cosine, sin.
Okay, so cosine, okay, you're just locked on sine and cosine. That's okay, it makes it easier for us to put the
That's what I'm
calculator.
saying, that's why I picked it.
All right, so cosine, actually, take the cosine of 222, or 22.200, cosine of 22.2645.
0.9254446.
All right, put that in the memory. Now, we're going to take the cofunction class, sine, of the co-angle. So you're going to, on your calculator, maybe do 90 minus that. What is the complement of 22.2645?
67.7355.
All right, take the sine of 67.7355 now. Does it match the value in the memory? Again, doesn't matter what angle you make up, the sine of one always equals the cosine of the complement because they're complementary functions. Questions on this? Now, it gets a little dicey, I suppose, if you had this, for instance, the secant of theta plus 11 degrees. And we want to rewrite this in terms of the cofunction. Well, the first part's easy. What's the cofunction of secant?
Cosine.
Oh, that's the reciprocal. What's the cofunction of secant? Cosecant. And then for the angle, I need 90 degrees minus that.
78.
Well, 90 degrees minus theta plus 11 degrees.
I don't know what theta is.
We don't know what theta is, but we don't have to. We can represent this algebraically.
Oh, yeah.
I've got parentheses preceded by a negative, which tells me, class, I need to change the sign. So the theta becomes negative and the 11 becomes negative. We'll combine the 90 and the negative 11. 79 degrees, and we'll keep the negative theta, which doesn't combine with anything else, and there is the exact same thing as this, written in terms of the cofunction. Now, it wasn't a nice easy number, or it wasn't even a nice hard number, right? It's an algebraic expression at this point, but the process still holds true. Questions on this? Turn in your textbooks, or look across the page, I guess, to page 17. I want you to do, on page 17, numbers 19 to 29, the odd. Page 17, numbers 19 to 29, the odd. Rewriting each of these in terms of the cofunction. And make the function, the cofunction, either add or drop the co, and then 90 minus whatever angle they give you. What?
It's just secant b. I don't understand.
All right, secant and b. So we want to change the function to the cofunction. What's the cofunction of secant?
Cosecant.
Cosecant. Then we want to change the angle to the complement. How do we find the complement?
Minus by
90
90.
minus that. So in this case, can you do 90 minus b?
No.
So you have to leave it as
B.
90 minus b. You just put it in parentheses. So it's actually insultingly easy. I hate those insults.
I like it.
No, it's for pre-algebra. It's got review exercises and speed drills in it.
Oh, those are new. I didn't have those in pre-algebra.
No, you weren't here in pre-algebra. They didn't have them in pre-algebra either. He was here in pre-algebra. I started those last year. When they changed the book up on me, and I didn't like all the changes.
So I guess technically I didn't have those in pre-algebra, technically, because I didn't have them when I was talking pre-algebra.
Which one?
23.
Did you do the other ones yet?
I did the first two, yes.
Right. Remember what I showed a moment ago? I think I had you do it with me. That last example I showed. Do the same thing. All right, pencils down. Even if you're not finished, let's see how we did on these. So first of all, the sine of 25 degrees is equal to what, Chris?
Cosine combines 90, or 90 minus 25.
Which is,
65.
okay, so the sine of 25 is equal to what?
65.
Well, it's equal to cosine of 65 degrees. Okay, what is the sine of 25 equal to?
Cosine 65.
Cosine of 65. Okay, so Chris, number 21, the cosine of 20 degrees is equal to the?
The sine of 70
degrees. There we go. The cosine of 20 degrees equals the sine of 70 degrees. Number 23, Jamie, you mentioned you were kind of stuck here. We have the sine of 50 degrees minus a. and we want to make that equal to something. Well, first of all, if we're going to change this to rewriting it in terms of the cofunction, I'm going to change sine to cosine. And then just like we did on the last two where we did 90 minus 25, 90 minus 20. To get the angle, I just subtract 90 minus, but this time it's 90 minus the quantity 50 degrees minus A. And I'm going to simplify this algebra just a little bit. Walk me through.
So if we 40 minus A?
Well, 90 degrees minus 50 changes to the negative, and then this changes to a positive A. So my answer should end up being
the cosine 40 degrees plus A.
There we go, the cosine of 40 degrees plus A. That's what the sine of 50 degrees minus A is equal to. Does that make sense? How many had that? Okay, does it make sense now? Question.
Oh, no, I haven't.
Okay, question. All right, for the secant of B. Again, this is insultingly easy. If we're changing to the cofunction, Quentin, I'm going to change secant to, and I'm going to subtract whatever angle they give me from,
90.
but when I subtract B from 90 degrees, what do I get? 90 degrees minus B. There's my answer. That's it. That's how we have to leave it. What about the cotangent of 65 degrees, Quentin? How would I rewrite that?
Tangent 25.
Tangent of 25 degrees. And for the last one, the cosine of C plus 15 degrees. What do I need to do here, Chris? Walk me through.
Okay, so you're going to write cosine C plus 15, and then you're going to take the cofunction of cosecant.
Of cosine,
Cosine, sorry.
which is
sine.
sine.
And then you're going to put the 90 in there, in the brackets.
Whatever.
Okay, cool. And then
Brackets are hard. I'm lazy.
minus 15
Minus what?
minus C plus 15. And you're going to want to change the negative, but you're going to change the sign. And then you're going to subtract. That's going to give you 75 minus C.
There we go. So the sine of 75 degrees minus C is equal to the cosine of C plus 15 degrees. Questions on this? We feel like we've got it now. All right. Now look at number 31. It says use the identities to verify each statement. Do you notice in that first denominator it says tangent of 90 degrees minus A? 90 minus angle always is a way of finding the complement, right? Going all the way back to the beginning of geometry, you find a complement by saying 90 minus that, right? So if we have a complementary angle, I could also have a complementary function. So what's another way I can rewrite tangent of 90 minus A? Anyone? A. Whatever the complement is being, right? The cotangent of A, tangent of 90 minus A, these are the same thing. So it says verify that the tangent of A is equal to 1 over the tangent of 90 minus A. Well, in other words, verify that the tangent of A is equal to 1 over the cotangent of A. Well, what is 1 over something? That's another way of saying the reciprocal. What is the reciprocal of cotangent? So the tangent of A equals the tangent of A. Does that make sense? Look at letter number 32. It gives us that the sine of B is equal to 1 over the secant of 90 degrees minus B. Well, what's another way of rewriting secant of 90 minus B, Jamie?
So it would be the sine cosecant.
Cosecant is the cofunction, so the cosecant of
B.
B. Because this is the cofunction of a coangle. The coangle is B, the cofunction is cosecant, so we have that the sine of B is equal to 1 over the cosecant of B. But again, 1 over cosecant, that's a reciprocal. What is the reciprocal of cosecant, class? Sine. So apparently, yes, the sine of B equals the sine of B. That makes sense. All right, so number 33, Chris, what should we do first to simplify this, to verify that, yes, that is indeed a true statement?
No, the cofunction is, which cofunction of COS is sin or sine. So then you're...
Point number 33. This one here? Are you doing the cofunction right here?
Oh, yeah.
Well, there's nothing here to indicate I should take a cofunction. What indicates there should be a cofunction right here?
The 90 minus.
The 90 minus, because that indicates a co-angle, a complementary angle, which indicates a cofunction. So this is where we're going to go with the cofunction. Let's leave the cosine of c alone for now.
Secant.
Right, so we're going to rewrite this as the secant of,
90 minus c.
well, we already have a 90 minus. Just c. The cosecant of 90 minus c is the same thing as the secant of plain old c. Plain old function, plain old angle. Cofunction, co-angle. From here then we know that the
Cosecant. No.
what does 1 over something always mean? One word.
Oh, reciprocal.
Reciprocal. So we have a reciprocal, so we know that the
Reciprocal
of
secant
is,
CSC. No.
that's cofunction. The reciprocal of secant is,
Cotangent.
no, the reciprocal of secant class is,
Cosecant.
no,
Cosine.
cosine. So the cosine of c has to equal, well in this case the reciprocal of secant is cosine, the cosine of c. You've got to have these memorized. Got to have them memorized. Number 34. 34. It says that the cotangent of d supposedly is equal to 1 over the cotangent of 90 minus d. All right. Quentin?
Cotangent B equals 1 over tangent B.
How did you get tangent of d?
Tangent is the reciprocal of
Not the reciprocal. Tangent is the
cofunction.
cofunction, and this of course is the 90 minus complementary angle. So the complementary function, complementary angle. Okay, then
Tangent is the reciprocal
of,
cotangent.
so therefore the reciprocal of tangent could be rewritten cotangent of d, which yes, does equal the cotangent of d, and we have verified that statement. Okay, questions on cofunctions and reciprocals. I like this little exercise because it helps us to balance reciprocals and cofunctions all at the same time. Questions there. So let's take a look at this here. Number 35, write that statement down on your paper and let's see, is that true or is it a lie? Number 35. Heads off hands. Keep yourself alert with good posture. The cosine of 10 degrees times the cosecant of 80 degrees equals 1, they say. I'm going to put a little question mark here. We're going to question, is that actually true? Well, how can we tell? Well, here's the thought. To get a single number, it would help if we had matching trig functions, right? Can cosine turn into cosecant, though? Or can cosecant turn into cosine? What can cosine turn into? There's two possibilities. Class, cosine can either turn into sine if I use a cofunction, or cosine can turn into
Sine.
that's sine. Or cosine can turn into
Secant.
secant if I use a reciprocal. Let's use one of those. Jamie, which one?
I see where you're going with this.
Secant.
Okay, so we're going to rewrite the cosine of 10 as, well, how would I rewrite that? Cosine and secant, how are they related?
They're reciprocal.
They're reciprocals. So the cosine of 10 degrees is equal to
1 over 10.
1 over the secant of 10 degrees. These are reciprocals of each other. So the cosine of 10 and the reciprocal of the secant of 10 are the same thing. Again, still questioning, does this equal 1?
Yes.
Well, at this point now, the reciprocal of secant 10, but I still don't have matching trig function, right? Secant and cosecant don't match. Can secant turn into cosecant, class?
Mm-hmm.
Yes, it can. How are secant and cosecant related? They are
Cofunctions.
cofunctions. So that means I can now rewrite secant as cosecant. But if you rewrite the function as the cofunction, the complementary function, you also must rewrite the angle class as the complementary angle. What is the complementary angle of 10? 80. And if I were to put this over 1, Thoughts?
Cancel.
They cancel. And I'm left with
1.
1. Does indeed equal 1. That is a true statement. You could check it on your calculator, I suppose. Try the cosine of 10 degrees times, now you can't plug in the cosecant directly, but you can do the sine of 80 and then take the reciprocal of it. So cosine 10 times the sine of 80, then hit reciprocal, equals, and it should come out to 1.
0, 1.
You did something wrong. Should come out to exactly 1. So we have the cosine of 10 times, now we can't do cosecant of 80, but I can do the sine of 80 and hit the reciprocal, equals. And sure enough, it equals 1. Let's take a look at number 36. Write that one down now. Number 36. The sine of 27 degrees times the cosine of 63 degrees, yes or no, equals 1. Now, we could just plug it into the calculator and test, but we're not going to do that yet. We'll do that at the end. For now, we want to try to do what we did here. Get something to match so you can try to cancel something. Can sine turn into cosine or cosine into sine, class? Yes, how? No, not reciprocal. Cofunction. So one of these needs to be rewritten. Which one, Quentin? Cosine. Okay, so we're going to leave the sine of 27 degrees and we're going to rewrite this as the sine. Well, that's a cofunction. If you change to the cofunction, class, you must also change to the coangle, the complementary angle, which is 27 degrees. All right, wait a second. The last time we got 1 because cosecant 80 and cosecant 80 canceled, right? Do sine of 27 and sine of 27 cancel?
They can't put sin 27 the first one, the first one.
The first one over 1?
Yeah.
And the second one over 1. And now,
but do divide instead of multiply, because then you can do
well,
reciprocal.
well, you can't change, I mean, it was given as a multiplication, so I can't change it to a division.
It's not going to cancel them.
It's not going to cancel. Check on your calculator. Sine of 27 times cosine of 63. Sine of 27 times cosine of 63.
0.2061.
Yeah, that doesn't equal 1, does it? Okay, that was a lie. All right, let's take a look at number 37. The secant of 15 degrees times the cosecant of 75 degrees, yes or no, equals 1. Well, again, the goal is to make the functions match. Make the trig functions match. Can secant and cosecant be made to match?
Yes.
Yeah, because they are
Cofunction.
cofunctions. So I could rewrite, for instance, the secant of 15 as the cosecant of 75, the cofunction of the coangle. And of course, this is already, wait a second, are these going to cancel though? No. So is it going to equal 1? No, it's another lie. Look at number 38. The tangent of 25 degrees times the tangent of 65 degrees equals 1. They already match. Do they cancel? Well, the functions match, but the angles don't match. Remember, to cancel, I would need both the function and the angle. Is there any way, shape, or form to get the angles to match up? What's true of these two angles? They're complementary. So therefore, I can make the angles match if I used a complementary function or a cofunction. But in doing so, not only must the angle change to the complementary angle, but the function has to change to the cofunction, in this case, cotangent. All right, so now I've got matching angles, but not matching functions. Is there a way to keep the 65 and change cotangent and tangent to match? Cotangent is not only the cofunction of tangent, cotangent is also the reciprocal. So I could rewrite this as
1 over 65.
but when you take a reciprocal, you get the reciprocal function. So the reciprocal of cotangent is 1 over tangent, not 1 over cotangent, but 1 over tangent, 65. Ah, sure enough, is this going to equal 1, class? Yeah, check it on your calculator. Tangent of 25 times the tangent of 65. Does that equal 1? Sure enough. Look at number 39. Have the cosine of 45 degrees times the cosecant of 45 degrees equals 1. Can cosine and cosecant be made to match, class?
Yeah.
Okay, what kind of functions are they with each other?
They can't.
They can't. Oh.
There's no, and that's wrong.
Well, what can cosine become? One of two things.
It could become the SEC.
It could be secant or sine, right? If I make it secant, that would be using the reciprocal. So I could change cosine 45 to
45.
Secant 45. Secant.
reciprocal.
1 over secant.
There we go, 1 over the secant of 45. You change it to a reciprocal, 1 over the secant of 45.
It can.
Okay, and of course, we still don't have matching functions, but Chris just noticed
Its cofunction is SEC.
the cosecant's cofunction. So if I leave the 1 over secant 45, then I can change this into its cofunction.
Secant.
And if I change the cofunction, I also need the complementary angle.
45.
And sure enough, they're going to.
Cancel.
So even though cosine and cosecant can't become each other, they can both become secant. One by means of a reciprocal, one by means of a cofunction. And they were able to cancel each other that way. Look at number 40. We have the secant of 25 degrees times the sine of 75 degrees, all equal to 1. What function can both of these become? Because secant and sine can't become each other. But secant can become blank, and sine can also become blank through a different means. They can both become cosine. How does secant become cosine, class?
No.
Reciprocal. So what will secant 25 look like if I change it to its reciprocal? Chris?
1 over
We just said it, class.
I know.
Cosine of
25.
25 degrees. How will sine become cosine, class? Cofunction. So Jamie, what does it look like when we make it the cofunction?
It'll be the cosine, 25 degrees.
Wait, is 25 the complement of 75? What's the complement of 75, class? 15. Right? So 15 and 75 add up to 90, right? Oh, so we even got matching functions, but we couldn't get matching angles, could we? So can they cancel? So are they going to equal 1? No. That's another lie. Questions on this? Again, the other reason I like this exercise, like the last one, helps you to practice with reciprocals, cofunctions, seeing how they're related but separate ideas. We feel like we understand the difference between cofunctions and reciprocal functions. All right, now we can actually use cofunctions to help us solve certain trig equations. Next section, your notes. Trig equations with cofunctions. Trig equations with cofunctions. And we're going to learn to solve all kinds of trig equations later in the year. This is just kind of a special subset of trig equations. And I want you to look at the example problem on page 16. They give us that the sine of a plus 15 degrees is going to be equal to the cosine of 2 times whatever that angle is. The question is, what is a? For what value of a is this true? This is not an identity. This is not always true. But for a specific value of a, it will be true. Let's see what we do. Step number 1, make the functions match. Get the same function on both sides of the equal sign. Step 1, writing this down, Chris. Get the same function on both sides of the equal sign. Make them match. If sine and cosine cannot be made to match, you cannot solve this problem. Can sine and cosine be made to match, class? Yeah. I could turn, well, how are they related, sine and cosine? They are not reciprocal. Cofunctions. So here's the deal. On one of these two, I've got to change to the cofunction and the co-angle. How do I change to a co-angle?
Reciprocal? No.
90 minus. Complementary angle, 90 minus. Would I rather do 90 minus right here or 90 minus right here?
First one.
If you want to do 90 minus a binomial, I hate binomials. Then you're changing signs and parentheses and all that nonsense. Remember there were a couple hard problems we had earlier? This is the easy side. I'm going to find the easy side, and I'm going to change this side to the cofunction. The sine of 90 minus 2a. And over here, I'm going to leave the sine of a plus 15 degrees. Now, it would not be wrong to say the cosine of 90 minus a plus 15 equals the cosine of 2a, right? You have two options. Either of these is fine. I hate this, okay? That's just a mess. Find the easier side, the easier looking angle, do the 90 minus on that side. Leave the other side alone. The point is, though, we have the same function on both sides, right? This next step down, cancel the matching trig functions. Cancel the matching trig functions. So whether it's canceling away the two cosines, or whether it's canceling away the sines, cancel away the matching trig functions. Now, here's why I like coming over here. We're going to ignore what we started here. If the functions are gone, I don't need the parentheses anymore, right? We said this before, if you've got a grouping on one side of an equal sign and there's nothing else with it, you don't need the grouping, right? It's like you three getting together and saying, all right, we are going to be a group of seniors in pre-calculus and we're not going to let anyone else join our group. There's no one else in here to join your group, right? You're by yourselves. This is by itself. So it really just becomes a plus 15 and 90 minus 2a. Easy enough, parentheses gone. Step number 3, solve. Like you would any other equation. I've got an a, we used to call it an x. I've got an a on both sides. Always get rid of the little one. Which one's the little one, the a or the negative 2a?
Negative.
Negative 2a. Let's bring the negative 2a over here as a. Positive 2a to get 3a. And if we're bringing the a over to the left, let's ditch the 15, remember, over to the right. Been a while since we solved equations, hasn't it? Let's bring the 15 over to the right-hand side as a. Negative 15 to get 75 degrees. And then we just got to divide both sides by, stay with me, 3. And when we do, we get a is equal to 25. Only if a is 25 degrees is this a true statement. Let's check. 25 plus 15, 40. So the sine of 40 is supposedly equal to 2 times 25?
50.
The cosine of 50. Is that true? Cofunction, coangle. Yep. Or you can check it on the calculator. Try the sine of 40, try the cosine of 50. Yes, it does check out. Only when a is 25 degrees is that true.